Hello. So I'm starting a channel for teaching 3D graphics. I think it's something that doesn't have a lot of resource on, and it's most people just use APIs and teach libraries that does 3D graphics without going into the details of it. And this channel is dedicated to teaching the foundations of knowledge. And if you have the knowledge about 3D graphics at the fundamental level, then you don't have to rely on any API. The skill will carry over to almost anything. I think it's valuable. Everyone should have that if you want to get into 3D graphics. And I think the best starting tool will be Shadertoy because it requires no boilerplate, requires no setup, and it is also very easy to set up on your own machine if you don't have access to browser. You can just do a simple OpenGL graphics boilerplate code and write a simple fragment shader for a quad. But as for now, I think we'll stick to Shadertoy until we get a firmer grasp on how 3D works. So you can just type in shadertoy.com and get into the website. One note on the website is that it's very laggy sometimes. When you go to the homepage, all of these shaders will all run at the same time. So what I deal with, how I deal with that is create your own account, and in my account you can go to config and there's an option for preview. So if you check this, use previews, that means when you go to Shadertoy, it only show a preview image instead of running all the shaders at once. So you can browse through everything without having to wait like 40 minutes or something. So once you have an account, go ahead and do. What this does is it just creates a new shader. What you probably want to do is name your shaders, put your names, tags, and descriptions, then click on submit. One thing I have to say is this tutorial is oriented towards programmers. It's a graphics tutorial for programmers. So if you're not a programmer or not someone familiar with the family of C languages, do not expect me to teach you the basic C syntax. I'll only assume what you know already, then teach what's specific to GLSL or graphics, and that's all I will do. I will not explain the basic C syntax or stuff like that. So let me just delete all the code that's generated and explain to you what this function is. This is just like a C function signature, void as a return type, and the function name is main image. What these two arguments, you might not have seen the out and in keyword. It's out is when an argument has the out keyword in front of it. It's like when you assign, that means you the function wants to assign some value to this argument. After the function finishes, it'll take that value out to whatever previous whatever code is calling this function. So it's kind of a pointer, and you're writing to the pointer as a return value into the address. In just specifies that if you write anything to this argument, it will not carry over to any other parts of code besides this function. So it's really just, if you delete it, it's just a normal C argument. There's nothing special about that. Vec4 and Vec2, they're the two fundamental types in GLSL. Well, not two, there's really four. What a vec is, it means a vector. It's just a tuple of values and number after it. For example, vec4, it just means there are 4 elements in the vector. And if I type vec3, vector, this is the constructor for vector. If you just input one value, then this value will become the value for all 3 elements inside the vector. You can reference each element inside the vector by X, Y, or Z. That's just the convention for stuff. You can even reference, well, let me just do this. There are 3 arguments in the vector. So for now, it's all zeros. We could access the first element through dot x or dot r. We can access the second argument as dot y or dot g. The third argument is dot z or dot b. It's very clear why we can access them the way we can access these elements using x, y, z. That's just the convention for denoting your coordinate system. RGB, what these stand for is red, green, blue. It's the standard way to encode color in graphics, usually. That's what people do. And you usually use vec3 as the position vectors or to represent a color value. So I'll go back to this. What frac coordinate is it encodes a coordinate for, well, I guess if we explain what Shadertoy does. The entire code you write, what Shadertoy does is, in memory, computers represent your image, whatever image you're rendering, as a grid, a two-dimensional grid, and in each grid there's a cell, right? And the cell, we call this pixel. What Shadertoy does is a good substitution model just to put in your head. There's no guarantee that it does it this way, but you can always assume that it does it this way. It is not. You write this code, and the shader code you write will be executed for all the pixels inside the image. So whatever this pixel is, the computer wants to write a color to this pixel. What it does is it sends the coordinate of this pixel, which I'll talk about later, to this function call via the frac coordinate. So this is the coordinate of the pixel that we want to shade, and the color is the color output for that pixel, which after your program is run, you should have written some value to the frac color, and that frac color will be assigned to that pixel. It will do that for all pixels on the frame buffer or image. And then after you will have after all of that, you'll have a complete image to present on a screen. So one thing you have noticed is you cannot, when you process one of the pixels, you cannot access any of the other pixels. It's made this way is because the shaders are usually run on GPUs, and GPUs are faster than CPU for image processing because everything is run in parallel. A good substitution model, again, this probably doesn't happen this way, is every single pixel, the shader code will be run on every single pixel in parallel at the same time. Again, that doesn't usually happen. What actually happens is the shader is run in 2x2 little packets of pixels, and there's reasons why they do that, which I'll not discuss as of right now. So that's the gist of it. If I put vector, if I just assign the vector, or let me name this color, right? And what I can do with color is frag color. I can assign the fragment color to be color, but there's something wrong, right? I've said that colors are represented by RGB values. That's 3 components, but our output frag color here is 4 components. Well, why is that? That's because the convention of color, again, usually what you want to do, what most people do, including people who wrote Shadertoy, is there's a 4th element or 4th component to the color vector. It's called A or alpha. And the equivalent in 4D is W, the homogeneous component. What alpha is it's a number range between 0 and 1. It's if you haven't heard of alpha channel, you will know what it is. It's just the number representing the transparency of the color. So if alpha is 0, that means this color is entirely transparent. If it's 1, then that means this color is completely opaque. However, it doesn't have much meaning here because we're literally replacing the color. We're overriding the pixels instead of blending the pixels. So the alpha channel inside the color do not have any meaning. What we can do is invoke the vec4 constructor, give it the give it the components of color. And for the fourth component, the alpha channel, we can just give it 1. And this will be 0. This will be black, and that is because the colors are all zeros. Again, in each component, 0 represents, nothing, black, and as each component's value go up, it takes more. If I increase the value of red inside the color component, then that means there will be red in the color. There will be more green in the color. There will be more blue in the color. If there's no red, green, blue in the color at all, then that will be black, obviously, right? And if I put this color as 1, that will be completely white. And if I have 1, 0, 0, be completely red. One very convenient syntax trigger in GLSL is that you could create temporary vectors with a convenient notation. For example, I could just do color.xyz. What this does is, again, it creates a 3D vector with just these elements as the first, second, third element. And I can do stuff like x, z, y with z's and y switching places. I highly recommend you read the specifications for GLSL, as I will not go into greater depth than this. I just want you to know that this will return the vec3 with xyz in it, or just color, which is what that is. And surprisingly, this works because vec4 constructor can take a vec3 and the floating value to construct a vector. You can almost expect anything like this to work, any combinations of vectors to work for any vector constructors in the same way. Right? So this is the basic introductory to Shadertoy. As we move on, if there's any specific details that I fail to mention, I will fail to mention in this video. I will mention as we move on.